Hello, everybody. Today is December 28th, 2020, and as usual, I post solutions to the daily problems that I post during a week on my page on Facebook, Math Tribe. If you like to see those questions, please subscribe to like my page. It's called Math Tribe Society. So yeah, on my page I post daily questions from math that goes every year in here in Canada, and a lot of kids participate in this contest. It's very interesting. Some of the questions are really challenging. Today we'll have one or two of them. Most of them are okay, but there are some challenging questions there. So today I stream on two platforms. Actually, I experiment. I'm pretty new to all this technology. So bear with me. I'm learning as I go. And yeah, let's start. Let's start. And let's start. So first question is, an integer p is a prime number if p greater or equal to 1 and the only division of p 1 and p and itself. Let m be the product of the first 2002 prime numbers. How many zeros are at the end of the number m? So we're given that p is a prime number, okay, and most of them, except one, are odd numbers. So one prime number which is even, and it's 2, right? And the only combination we can have to get 0 at the end is 2 times 5, right? So it will be 10, and then this 0 will stay at the end forever. It doesn't matter how many prime numbers we're going to multiply, right? This 0 will stay at the end of this multiplication, because 0 times any number will give you 0 at the end. So the correct answer will be B, 1, 1, 0. So next question. In some of the small squares of 2x9 grid, there are coins. Each small square either contains a coin or has a common side with a similar square containing a coin. The number of coins in the grid must then be at least. So we need to figure out what's the minimum number of coins we can place in those grids, such that each square contains a coin or it's bordered with the cell that has a coin. So let's start from the first one. So we're going to place coin here, right? So then next one must be, so then this grid border with the cell that contains coin, this cell borders with the cell that contains coin, right? So what about these cells, right? So then we need to place coin here, right? So in this case, our condition is satisfied, right? So then this cell border with the cell that contains coin. So now, what about this cell, and this cell? Okay, so it looks like we need to place coin here, right? And now we see that we have a pattern here. So then we here and here. And then we can check, right? So this cell borders the cell that contains coin. This cell borders with this cell. So this cell borders with this cell. I'm trying to draw arrows. Right? And we have this one. So now our conditions are satisfied and we have 5 coins. So minimum number of coins is 5. Okay, next question. 4 children bought a birthday present for their father. One of the children hid the present. Their mother asked them who had hidden the present. The 4 boys involved made the following statement about the offender. Alfred said it was not. Benjamin said it was not me. Christian said it was Daniel, and Daniel said it was Benjamin. It turned out that exactly one of them did not tell the truth. Who was the offender? So we know that only one child lied. Okay, so I built a truth table, right? So F means false. It means child that lied, and T means truth. Child that said the truth. Okay, so we have 4 possible scenarios. So we need to figure out which of them is possible. Okay, so we assume. Right? So we made 4 assumptions here. So we assume that Alfred lied, right? So Alfred lied. So it was not me, right? So he lied. So it means that Alfred hid the present, right? Benjamin said the truth, so this is okay. Christian said it was Daniel, right? So let's say Alfred said it wasn't me, right? So it was Alfred, right? So who hid the present. Now, if Christian said that it was Daniel, and Christian said the truth, so it means that Daniel hid the and Daniel said it was Benjamin. So, and Daniel said truth, it means that Benjamin hid the present. So now we have 3 children the present. So this is impossible, right? This scenario is impossible. Said the truth, so it wasn't him, right? So it wasn't me, so he lied. It means that Benjamin hid the present. Then Christian said it was Daniel, so it means Daniel hid the present. And Daniel said it was Benjamin, and it means that Benjamin hid the present. So now again we have 3 children who hid the present. So again, this scenario is not possible. We know that only one child, it says here, hid the present. So third assumption, Alfred said truth, it wasn't him. Benjamin said the truth, it wasn't him. Now, Christian said it was Daniel, right? It was Daniel, and Daniel said it was Benjamin. Okay, so this scenario is not possible again. Why? So because here we don't know who hid the present in this situation, right? So if Daniel, if Christian said it was Daniel, but he lied, right? So it wasn't Daniel. So then who hit the present, right? So we don't know who hit the present. So the only situation left is this one, right? So Daniel, correct answer is D. Next question, son John and his son Peter and his son and John and his son went fishing. Peter caught as many fishes as his son did. John caught 3 times as many fishes as his son did. They caught together 35 fishes. The name of Peter's son was Luke. What was the name of John's son? Okay, so let's assume that Peter and Luke X number of fishes, right? And Peter and he caught 3 times as many, right? So altogether, so we assume that there are 4 people there, right? So altogether they caught X plus X plus Y plus 3Y, 35. We have 2X plus 4Y equals to 35. Then we so on the left hand side we have even number, right? So even number, and on the multiplied by 2, and on the right hand side we have odd numbers, which is 35, and it doesn't make sense, right? So we can't have even number on one side and odd number on the left side. So it means that there are three people there, right? So, and because Luke is Peter's son, so the only option we have left that Peter is John's son, right? So there are 3 people there, and we can figure out how many fishes each of them caught. So it means X plus X plus 3X equals to 35, 5X equals to 35, and X equals to 7. Right? So Peter and Luke caught 7 fishes, and John caught 21. Okay, next question. Did I skip something? No. In a group of boys and girls, after 15 girls had left, the boys that remained were twice as many as the girls. Then 45 boys left, and it turned out that of the remaining, there were 5 girls for each boy. How many girls were originally in the group? First scenario, after 15 girls left, so initial number of, let's say G will be initial number of girls, initial number of girls, and B initial number of boys, right? So after 15 girls left, there were twice as many girls. The remaining number of girls were twice as many boys. Sorry, after 15 girls left, the boys that remained were twice as many as the girls. Okay, so this is the first scenario. And then second scenario, then 45 boys left, and it turned out that of the remaining, there were 5 girls for each boy, right? So this is the second scenario. So, and we just need to solve system of linear equations, right? So we can do it by substitution. So instead of g minus 15 in the first equation, we're going to substitute this left-hand side of the second equation. So we have 2 times 5 b minus 45 equals to b. So we open brackets. So we have 10 boys minus 450 equals to b. 9 boys equals to 450. So number of boys is 50. Okay. And then we substitute 50 into the first equation. So we get equals to 50. G minus 15 equals to 25. G equals to 25 plus 15 equals to 40. So number of girls is 40. Next question. Introducing an invention, we can reduce production expense by 50%. Introducing another invention, we can reduce it by 40%, the rate, what's left. And introducing third invention, we can reduce it by another 10%. By how many percent will the production expense be reduced after introducing all the 3 inventions at the same time? So after first invention was introduced, the expenses have been cut by half, so only half of them stayed, right? So after we introducing the second invention, right, so 40% of the remaining expenses will be cut. So 40% is 2/5, right? If we convert 40% into a fraction, it will be 2/5. So we have 2/10, right? So how much expenses left? So it will be half minus 2/10. So it will be 2/10 equals 3/10, right? So it will be 30% expenses left. So we introduced third invention, and then another 10% was cut. So 3/10 times 1/10, so it will be 3/100, right? And then 3/10 minus 3/100, so we have 30/100 minus 3/100 equals 27/100. It's 27% left. So 27% of original expense is left. So by how much how many percent was cut? So 100% minus 27% equals to 73%. So the expenses have been cut by 73%. And the last question, it's a little bit tricky. So it was kind of hard question, right? So how many numbers from 1 to 10 to the power of 2002 have the sum of their digits equals to 2? Okay, so I approach the solution by building a pattern, right? So we start from 10 to the power of 0, right, which is 1. So it gives us a group of from 1 to 10. So we have only one number in this group, right, in ones place value, right, of ones. So only one number. So in tens, in value group of tens, we have two numbers. It's 11. In hundreds, we have three numbers, right? And then in thousands, we have four numbers, and so on. As we introduce another place value, we have additional number such that its digits add up to 2, right? So how many in total? So we have, as we can see, so we have 1 here, 2, 3, 4, 5, and so on. So if we have 2002, so then we have, right? So we have altogether we have from 0 to 2001. So we have 2002 numbers, right, including 0. So we have arithmetic sequence here. So to find sum of arithmetic sequence, let's try to remember the formula. So it's n times a1 plus a2 an divided by 2, right? N equals to 2002. Our A1 equals to 1. And our A2002 equals to 2001. Okay? So we have 2002 times 1 plus 2001 divided by 2. So we have, if we calculate, we have 2002. Let me open. Sorry, I think I'm doing this wrong. Wait. I'm doing this wrong. Partially. Let's. Okay. So we have n is equal to 2001. A1 equals to 1. So 1 . So it will be 1 plus 2001 divided by 2 gives us 101. And then 1001 times 2001 gives us, 2,003,001, and then we need to add 2002, and we get this is the correct answer. Okay, so why this? So I did it. I give you wrong explanation, right? So first, we need to consider. Yeah, I told you it's a tricky. Was a little bit tricky question. So I only consider numbers that contains ones in them, right? So these ones. So we'll have, right? So we'll have. So we have 1, 2, 3, 4, 4, and so on, right? So for each place value, we'll have digits as a place value, right? One less, right? So that's one. That's why we have from 1 to 2001, because we're skipping this one. We're skipping ones, right? Place value of ones. So we'll have from 1 to 2001. So we have numbers from 1 to 2001. To find sum of this arithmetic sequence, we're using these formulas. And then we'll have to add all the numbers that has 2 in them, right? So, and we'll have exactly 2002 values, numbers, right? So, and that's why the solution is 2,005,003. Yes. So, and I think we're done for today. Yeah, I'll post more questions this week, and we'll meet again next Sunday. Happy New Year, and I'll see you in a week.